Welcome back to the AI technical training. This is session 2. I'm going to dispense with the slides for this time around because we're going to be doing something a bit more practical this time. So you might see what looks like a very confusing graph in front of you, and it is a bit. And that's because the number of AI models, in this case we're looking at text-to-text models, otherwise known as LLMs, has exploded over the past year. So on this graph, you can see dates going along the bottom here. And if we were to go back to just over a year ago, you wouldn't have a huge amount of choice. So you'd have GPT 3.5, Claude number 1, which wasn't actually particularly popular or well known at the time and wasn't too accessible. And of course, GPT 4, which was released slightly after. And those were pretty much your only choices. But as time's gone on, we've had an explosion of models that was released. And you can kind of see that at the beginning here, most of the models that were released are in red, which means that they're closed source. Whereas now, we've got a lot more open weight models. If you're not sure what those terms mean, then take a look at the session 1 training from last time, which will explain that in more detail. So this session is going to be taking a look at how do you actually pick an LLM for your use case? Do you pick it based on price? Do you pick it based on its quality? How do you balance the two of those out? And we can kind of see on the left-hand side here, these models have been given a score. And we can kind of see the average of open weight models and the average of closed source models. And I'll explain exactly what this score means in just a moment. We can see that the average quality has gone up over time. And even with the open weights model, they're not quite at the same level as the closed source models. So that's probably one factor that you want to take into consideration when choosing your models. However, for a lot of cases, these models will be cheaper to run and might give you just as good results for your use case. The more complicated the thing is that you're trying to do, the more of a complex and capable model you will need to use. And so you might tend more towards closed source models, but they, of course, have their trade-offs as well. So looking at this list, we can kind of see that the top of the pack in terms of performance is still the venerable GPT-4, however slightly overtaken by GPT-4 Turbo, which is quicker and also cheaper. And sort of closely following up is Claude 3 Opus, which actually I find from personal experience in a lot of cases is more capable than GPT-4. However, your mileage may vary and a lot of things depend on your exact use case. This has been very recently updated because there was the surprise release of the Llama models, Llama 3, I think it was last week or the week before last. So as you can see, these things are just changing day by day. And one of the things that we'll look at in a future session is how to make your AI app able to switch seamlessly between models so that when something new is released, you can basically, with maybe not a click of the button, but by very, very minor changes to your code, actually switch out the model that you're using and change it for something that's more capable or cheaper or faster or whatever your optimal metric may be. Okay, so how do you actually do this evaluation? Well, if I go on to the Claude website here, which was published in March, we've got a bit of an introduction to Claude. We've got a bit of a graph here that shows the cost of each of their models. Haiku is the smallest, Sonnet is the medium model, and Opus is the largest and most capable. So as capability increases, so does cost. And then if we scroll a little bit down, there's a lot of metrics on this page. Most of these won't actually be relevant. So for instance, down here, if you're really interested in getting into the details, remember we talked about context length earlier, which is the amount of memory that a model can hold in one go. This kind of measures how accurate it is over that measure. So the things that you put in at the beginning might be better recalled than the things that you put in at the end, and this kind of charts this. A lot of this is very, very technical, and you may not need to go into that much detail, but you've got that information if you need it on what these are called model cards. They kind of vary from organisation to organisation. They do have a similar layout, but you can't exactly compare them like for like necessarily. But what I did want to point out is that every time these models are released, they're going to be trumpeting their scores on a set of standardized tests, which is what you can see on the left-hand side here. So for instance, we've got this test here called Human Eval, which rates this model's capability on coding tests. We've got things that measure it on math capabilities. And one of the most popular tests is MMLU, which is a kind of test that will take what humans are expected to know at an undergrad level across a wide range of subjects. And it's based on multiple choice questions. And this is how well the model kind of completes those. And you can see here that Anthropic have said that, hey, Claude has beat GPT-4, it's beat all of these other things, but you kind of need to take these with a little bit of a pinch of salt because the way that you do the tests are different, that they're given different numbers of chances to complete the test. So, some of this is a bit of marketing, so you just need to be wary of this before you jump on this usage of the model just by comparing these numbers together. If you really, really want to go deep into the weeds with this stuff, you can actually jump into the tests. So, for example, this is the MMLU test with some examples of the questions that are asked. So, for instance, there's an astronomy example here asking, why isn't there a planet where the asteroid belt is located? And the correct answer is that Jupiter prevented this material from collecting together to form a planet. So you've got tests in astronomy, business ethics, clinical knowledge, biology, etc. And it goes on and on and on. But obviously, the more that these tests are used and the more that this information is available on the internet, the more modern models can actually incorporate this into its training data so that it knows this information off by heart and it doesn't actually need to work it out. It's basically got it in its corpus. So these tests become less meaningful over time. So a different way of measuring the capability of these models is by basically asking them to compete head to head and ranking them in that way. And the way that these are done is by giving them an ELO score. So any of you who play chess or perhaps play some online games will be familiar with ELO. But essentially, the way it works is that each model is given a default ELO score. I'd say 1,000, for example. I'm not sure on the exact number, but it may be 1,000. And then they're running a set of head-to-head tests, one model against the other. The model that is chosen as the winner by humans is the one that increases its score, and the loser decreases its score. And if, for instance, you win against a model that's scored really low and you're scored really high, you lose a lot of points because you probably should have won against that model. Whereas if you win against a model that's it's slightly lower than you don't get that many more points because you kind of expect that to be a draw, and it's the opposite way around for the losing side. So these scores tend to sort of self-correct over time. And these are based on, I think it's roughly at the moment, 700,000 conversations that have been had between different models, and users have then ranked them based on their preference on the output. So ranking on number one on this kind of ELO score, which is what you saw on this graph here, is ChatGPT Turbo. That's the most recent release. You can see that it's not just ChatGPT Turbo, it's got a specific release date on it, followed up by another GPT-4 model, closely followed by Claude. And here's the Llama one I mentioned that has literally just been released. So as these scores fluctuate, you can kind of see the sort of changing user preferences as time goes on. Number of votes, the organization, the license. So proprietary is, of course, the closed source models. You've got different licenses. So this one is more of an open model. And then an important part here is the knowledge cutoff. So when it comes to scraping the data that goes into these models, they have to stop collecting it at some point. So this is like the most recent piece of current events that model knows. So for instance, this one here was cut off in December 2023, so it will know things up to that point. Other things, for example, this one is trained up to March of this year. GPT-4, the original kind of GPT-4, is only trained up to September 2021. So if you're looking for a model that has super up-to-date knowledge on events, then you need to take that into consideration. Whereas if you're looking at something more general, then that knowledge cutoff may not be quite as applicable for your use case. So you can use this to get a sense of the models, their capabilities, etc. So I always find that this is a kind of better metric because it's based on humans actually interacting with the model and voting different models versus more of an artificial metric that you might see with this. Okay, moving on, you can kind of see the difference between all these models. So this is on the OpenAI specification page. So you can kind of see here there's all of their models, the training data, and the important part that you don't see in this view here is the context window. So again, this is a piece of terminology that we introduced last time. If you're not sure what that means, then you can review session 1 for details on that. If you're looking at something which is able to hold a very long conversation or process a lot of information at once, you want a long context window. So you kind of have to combine the information that you have on this ranking here with the information on the vendors pages that tell you what the context window is. So if you're interested in this, is chat.lmsys.org. So chat.lmsys.org, which will take you to this scoring table. And you can also filter it down by the type of task as well. So for me, I'm quite interested in these models' coding ability. So I'll pick the coding score, and that will resort the table to show me the ranking so you can see how that's changed. How models have moved up and down on that ranking, specifically for coding. You've got other things here, so English, Chinese, French, etc. So you can pick exactly what use case that you're interested in, and then you can see the specific ranking for that use case. Another thing that is of great importance is the pricing of the models. So for instance, if again I go on to OpenAI here, we can see that they price their models based on 1 million tokens. And tokens, again, is another concept that we introduced last time. You can kind of think of it in words. Doesn't quite match up with words, but you can kind of think of that as what tokens means. So for instance, we've got the GPT Turbo model here, and we're told that based on 1 million input tokens, you will be charged $10, and for 1 million output tokens, you will be charged $30. So what's the difference between an input token and an output token? When you actually write your query to the AI model, so if you've used ChatGPT, that's the stuff that you type into it. That is the input token. The output tokens is the response that the model gives back to you. And they're charged differently because it's actually more computationally expensive to produce output tokens than it is to do the analysis of the input tokens. So when you actually come to calculate your expected pricing of these models, you have to take your specific use case into consideration. So if you're looking at getting a massive swathe of input, so say you're doing some legal analysis and you've got a PDF that's pages and pages and pages, then you're going to be using more input tokens than if you ask it to just produce a very brief summary. You're going to produce in very few output tokens. Whereas if you're putting in a very, very short prompt, write me a story about whatever the topic may be, you're going to be using very few input tokens and a lot more output tokens. So you have to then take these into consideration. So there's a switch here to show it per 1,000 tokens, but the industry has generally settled upon 1 million tokens as the benchmark. So when you compare pricing, if the vendor isn't using 1 million tokens as their basis, then you'll need to do a bit of calculation to work out the difference there. So there's a very, very helpful table here, which shows, as of today's date, the kind of anticipated cost of different models. We can probably share this somehow, or you can take a screenshot now as the video is playing. This will change obviously over time as the computational capacity goes up, GPUs become cheaper, and other non-GPU chips are introduced. So for instance here, Grok, this is not to be confused with Grok with a K, which is the Twitter X, XAI bot. This is another very similarly named provider. They use different chips to GPUs, and they're able to produce tokens very, very cheaply. So you can see here that we have this mixtural model, which is able to run on Grok at a total cost of $1.08, whereas this one here is the same model, but running on Mistral, which is the people who made the model, but they cannot actually provide those tokens as cheaply. So sometimes you see the same model listed in several times by a different provider, and that's because it's an open weights model and it can be run on different providers. So right at the top here, we have this one, which is very, very cheap, but is it any good? whereas we have Claude 3 Opus weighing in at much more expensive, but as we've seen from the ranking, it's rated much more highly. So the way that this is calculated is it's predicated on the fact that you're likely to have 3 times as many input tokens as output tokens. So the $60 here is 3 times 10 plus 1 times 30 equals 60. Again, with your own particular use case, the balance between input and output tokens may be different, so you'll need to make an adjustment based on that to get the pricing for your own use case. And then again, if you say, actually, I'm going to go super cheap with this one, then you can compare it on this chart here to see where it sits. Where are we? I think it's this one, 8 times 7 billion. Yeah, 8 times 7 billion. So actually, this is kind of a bit low, but if you're asking it to do very, very simple tasks, that might be absolutely fine, and then that will run super cheap. When you're producing your AI app, you have to remember that users are going to come onto your app, they're going to use your AI system, and at the back end, you're actually going to have to pay to serve those tokens to your user. So, for instance, if you're running with OpenAI, then the user will come onto your site. They're not necessarily going to know that they're interacting with an OpenAI model. However, they're going to be submitting their queries. You're going to be passing those off to OpenAI to get the response. OpenAI are going to be charging you, and that's the point where you have to work out what you're going to be charging your user. And there's several different models for this. So there may be additional models to these, but here are some examples of some models that you may choose to use. You can kind of have a fixed price structure where you just charge the user once. However, that's kind of not going to work because they might go off and they might run hundreds or thousands of AI queries, which is going to cost you a fortune, and then it's going to cost you more to service that user than what you're getting in their single payment. So I wouldn't recommend that model unless it's for a very, very quick sort of subsidized trial or a demo, etc. That could probably work. You can look at charging them a regular subscription, and you kind of bake the average user into that price. So some users will use lower, some users will use higher. You might tend to find that it kind of distributes on a Pareto curve, whereas you have sort of 20% of your users using 80% of the cost, and your other users fall off either side of that. Again, that kind of depends on your application, but you kind of need to model what your anticipated usage is per user, and then build your subscription price based on that. That may be difficult to control, and you may need to change the subscription price over time to compensate for additional usage or increased usage as your platform becomes more popular. Another model that you can use is that you can produce credit packs. So, for instance, if you know that you're going to be charged an amount, and when you make these AI API calls, you will get a response that tells you how many input tokens there were and how many output tokens there were. And you can then use that to charge the user appropriately. So they may buy upfront bundles or packs of credits that they then spend over time as they use your service. They then dwindle down to 0, and then they can buy a new pack to top themselves back up. You can combine the subscription model and the credit pack model so that you've got the baseline cost of using the platform. And then anything above and beyond that, you then charge the user based on their API usage. You've also got another option with these open weights models, is that you can actually set up a server to actually serve these models yourself. That way you know you've got a fixed cost. So you may pay $1,000 per month, $2,000 per month to rent a server that's capable of running these models. Then you know that sort of no matter how much usage is actually used by these models, it's going to fit within that fixed cost that you're paying. However, that becomes quite difficult to manage because it's a lot more technically involved than using an API from one of these providers. And also, at some point, your server is going to get overwhelmed as your platform hopefully becomes more popular, your AI is more frequently used, and you're going to run out of capacity and you're going to need to add more servers and more servers. So that is an option, especially with open weight models, but that is more of a difficult way of actually managing things. Okay, going back to actually testing these models, how can we do that? So to see which model you might want to use, to see if you need to pick the sort of super high, super expensive models at the top, or if you can get away with one that's less capable but cheaper, you can start running some tests. And I introduced you to the OpenAI Playground last time. Hopefully you had a chance to sign up for an account, have a little play around with it, sort of see what the settings are and see how the different models on the right-hand side here perform in different situations. But just to give it a bit of a test. So you're going to want to make this domain specific. So what do I mean by that? Well, I tend to use a coding-based challenge because that's something that I can very easily judge, and I can very easily, using my own domain expertise, determine if that is something that is a good output or bad output based on the model. You'll want to adjust this based on your own use case, something that you yourself can judge very, very easily. And I'll leave that to you to kind of pick that based on your business. But if we pick that coding model, let me just take this as an example. So I've got a prompt kind of preset here. So actually, let me go and ask that of Claude. So if I go into Claude and I paste in my prompt, which is write code to produce the game Pong using HTML, CSS, and JavaScript. The left-hand paddle is controlled by the user. The right-hand paddle is controlled by the computer. You put everything into one HTML file. Let me pick Opus, which is that, if we go back to the page here, it's super expensive, but it's also, if we look at this chart here, really, really capable, kind of up there with GPT-4, and actually, in my experience, it tends to be better for some tasks. So I'm going to ask it to generate that and see what it produces. Let's give it a moment to do that. And you tend to find that the bigger the model, also the slower the output. So you can see this kind of spits things out really, really quickly. Sorry, very, very slowly rather, because this is the most capable model. We'll see another model which can produce this super quickly later. Just wait for it to actually finish, because unlike with if it's writing prose or something like that, this doesn't actually make sense until it's got all the way to the end. Give it a few more minutes to do that. Okay, this seems to be pretty comprehensive from what I can see. Brilliant. Okay, it's finished. So I'm going to take that, paste that into this, which lets me test what its output. Okay, that's looking pretty good. So we've got the computer paddle controlled on the right. We've got the ball, as we expect. But however, okay, so it's letting me control it with the keyboard. That's also moving the page up and down. That's not Grok's fault. That's just the way this page works. But as you can see, I can control the paddle. It's moving the ball. The computer is responding to me. It's kind of playing the game as you would expect. Just need to move it a little bit up. I missed it. Okay, great. But it's kind of done what I asked. So this is obviously capable of doing pretty complicated stuff, which is to generate an entire game. And as we sort of move further into this, you'll see how to actually leverage LLMs to actually produce the code that you need to actually build your AI apps. So not only are you building AI apps, but you're using AI to build the AI apps for you. Let me go back and change this. So I'm just going to take the prompt again and put that into Sonnet, which is the middle of the three models. Let's see what that comes out with. Now you can see that this is actually spitting out the code a bit faster. So the less capable the model, the more quickly it tends to respond. However, is it going to be as good in terms of the code it produces? Let's try this again. Copy that code, put it into here. What have we got now? Okay, it's made a huge kind of screen, so I can't see everything, but it's different. As you can see, like the ball's circular. It's made the window a lot bigger, but we've kind of got what we're expecting. I can now control the paddle with a mouse, which I actually think is better than using the keyboard. It's easier to use. The computer is kind of playing pretty well against me. It's doing everything I would expect. Okay, great. So if I were to actually then decide whether to use this or not, obviously I would run a lot more examples. I wouldn't just rely on this one thing, but in terms of what is produced, that's actually pretty decent. So actually I probably wouldn't need to use Opus. I can probably go with a cheaper model, and actually is Sonnet on this list. Yep, so compare $120 for that input-output token mix to $24. So if it's just as capable for this use case, I would probably want to pick that one. Okay, let's try Haiku, which is their fastest model and the least capable. And as you can see, it's much quicker than it was previously. So you've got three things to take into consideration. You've actually got the capability, you've got the speed, and you've got the cost. You've also got the fact, is it open weights or closed source? Do you want to run it on your own server? Do you want to use the APIs? Okay, we're in dark mode now, apparently. So we do have some code in here for moving the mouse, but it doesn't actually seem to be doing what I expect. And also the ball's gone off the screen and we don't get a new ball. So there's some deficiencies here. So this isn't, here's a new ball, but that took a long time to appear. And I can't actually move my paddles, or I can't respond to what's going on. And the ball is passing completely through the paddle. So for me, this obviously is a bit of a killer. So is Haiku on here? Haiku is on here, so that's $2. So you've got $2 versus $24 versus 120. Obviously going up to $2 in my particular use case is breaking things. So it's not able to produce the results I expect at the $2 mark. One other thing I will just quickly show you is Grok. As I mentioned before, Grok with a Q, not with a K. This uses a different mechanism to produce code. It doesn't use GPUs, it uses their own chips. I'm going to pick Mixtral because it's reasonably capable. If I paste in that same prompt, I mean, that is just spat it out so quickly compared to Claude. So if you're looking at something that can produce tokens quickly and give a very, very quick response, then this is what you need. However, it has not followed my instructions to put things into a single file. Did I put that in there? Yes, I put everything into a single file. It's given me multiple files, which isn't what I asked. So I actually have to now do some work to put this together. So HTML is here. CSS is here. And the last bit is the JavaScript, which I'm going to paste into here. Is it going to work? Looks like no. At least not immediately. So, I've had to put this together. I'm probably going to have to do some debugging to make it work. So I don't think that that's exactly what we need, even though it's super fast. For my use case, that isn't what I need. Just try one more with Llama, which is the one that's just been released, Llama 3. So let's try with the 70 billion model, which is the big model, just to see how it does. This looks more promising. It's actually put things into a single file like I asked. Let's go back into here. Let's refresh and paste. Okay. Let's just fix the code for it. Okay. Again, this doesn't seem to be doing what we asked. The other opponent is on the opposite side. So there are some disadvantages to things running super quickly. But again, this is for my own particular use case. What you will need to do is to test these models thoroughly before making a decision. Once you've decided on a model that can actually meet the requirements of your use case, but maybe not exceed them, but at least do the minimum that it needs to, then you can compare the pricing tables, and then you can take some general guidance from the ELO scores, which I mentioned previously, put all of those together and actually decide how you're going to charge your users. If you could potentially offer a mix of models based on exactly what they're trying to do, you could have a really, really quick response as an initial response, and then a slower, more expensive response. You can do all of that kind of tiering. And then in a future lesson, we will cover how to actually make it so that your AI app can switch between models at the click of a button, so that as a more capable, cheaper, or faster model comes along, you can switch them out. So I hope this has been useful in terms of actually evaluating and choosing models. I'm looking forward to seeing you on the next lesson.